So for the start of class today, I'm just getting you ready for a little quiz. It's not long and it's not difficult, but these can be scary for a lot of people. What's the one that starts with sine squared and it keeps going? These are identities. They're a statement of fact that you can use in this unit. Finish it, please. What sine squared is, well, there's actually a lot of things you could say. You could say it equals 1 over cosecant squared. That's one thing you could say. But there was a little thing that had to do with a triangle. Yes? Amelia, you got this? Maybe not. Okay. What?
Sine squared plus cosine squared equals 1.
That's it. You guys got that? Remember that? Okay, good. Then, what if I said, in the middle of a problem, I got 1 minus cosine squared over sine squared. And I say, prove that's equal to 1. So, they're not going to be so nice as to say, use this identity to prove this. They're just going to say, here's the problem, deal with it. And you'll be like, okay, I feel like I recognize this cosine squared with the 1. Isn't there one of those identities that's got a cosine and a 1 in it? And then you go, oh yeah, it's this one. And then you'll go, okay, so I guess I just need to move this over there and rearrange it a little bit. And so what is this thing equal to? What is that? Sine squared. And then do you get a sine squared over sine squared? And so it's equal to 1. Can't I just say, yes, this is true? No, that's not a way to prove anything. So what you do is you swap one thing at a time and you go, okay, well that is sine squared. So I'm going to go sine squared over what the original one was sine squared. You don't have to like draw an arrow for me to show something that stayed the same. I mean, this blue arrow would be kind of dumb. Sine squared is sine squared. I don't need an arrow for that. But I do want to know what you did. And so I would want you to have done the black arrow to say, I changed 1 minus cosine into sine. And then, again, if you don't have anything, like you don't have to show me an arrow on this one. I know that's going to equal 1. But do you get it would have been really kind of tragic if a kid had left it right here because they would have been so close to getting full credit? Most kids, by the time we take this test, no. You've got to finish by making it exactly the same on both sides. And yeah, I know that's equal to 1, but you can't leave it that way. You got to say 1 equals 1. Now, another rule. Notice I never changed the right side. I never changed the 1 into anything. The right side stayed the same. Left side, I tweaked it a couple times. All right, here's another one. Do you remember what sine goes with? That's like a reciprocal. 1 over something. And cosine of theta was 1 over something. And tangent of theta was 1 over something. Would you please write those 3 out? They're called reciprocals. Okay, this is the part where I want you to start getting a little more comfortable in comparing and working with your partner because you're going to be working with them today to do the quiz. So I'm going to pause for a second while you remind yourself who that person is. I hope you said this was cosecant. And I hope you said this one was secant. And I hope you said this one was 1 over cotangent. But I hope some of you remember that tangent has another thing you could do that's got 2 functions in it. Would you please tell me what that is and also what's cotangent? It's got 2 functions, one on the top, one on the bottom, not 1 over something. Okay, make sure you get straight which one's which and compare with your partner. Pausing again. Sine over cosine. And the other one?
Cosine over sine.
Yep. All right, now I've reviewed a whole bunch of them. So imagine you're in the middle of a problem, and I'm not even going to say what's on the bottom of the problem, but on the top of the problem, you got a 1 minus cosine squared. What are you thinking you should replace it with? Your memory process should go something like this. Okay, I know it's got a cosine squared and I know it's got a 1. Oh, what's that one that has cosine and 1? Sine squared plus cosine squared equals 1. And if they want 1 minus cosine, then I'm going to put it like that. Cool. I got it. It's sine squared. Raise your hand if you had sine squared. Okay, good. This one's going to be trickier now, so pay attention. What if I had cosine squared minus 1 in the problem? I can give you a hint. It's not just sine squared, but it's sort of sine squared. Anybody? Talk to your partner, see if they know what to do. Okay, so here's what I'd do. I'd write out the original one, and then I'd go, well, I want it to be 1 minus cosine squared. You know, I can subtract cosine squared from both sides, and that's what I want it to be, but it's like backwards from that. You know what the math way to say backwards is? Opposite or negative. So then the answer isn't sine squared, it's negative sine squared. Who figured that out? Raise your hand if you figured that out. Nice job. Okay, so imagine the problem had been actually that equals negative 1. Prove it. I gave you all kinds of baby steps to kind of lead you up to this, so hopefully this will be pretty easy. Don't overthink it. If you're like, that's really easy, I mean it to be easy. Okay, so what does cosine squared minus 1 turn into? That can be turned into something else. Nope. All right, so I'm going to go back to the original one. I wanted this to look like 1 minus cosine. Do you see how it's exactly backwards of what I wanted it to be? So then I can put in backwards of this, or negative sine squared. So that's what you should put on the top here, is this can be negative sine squared. It's not sine squared, it's the opposite of sine squared. And then that over that equals 1, right? So then it's negative, and then it's 1 over 1. So then that's negative 1 equals, notice I never touched the right side, negative 1. Negative 1 goes all the way down. And there it is. How many of you would have probably had that one right? Okay, good. Now, let's go to, I'll teach you more about how to do common denominators and conjugates later after you take this little quiz, because this little quiz will not need common denominators or conjugates. All right, so there's a Schoology quiz. I think it's open and I think it's enabled. So somebody open it and see if it allows you to open it. Is it working? Is it just going slow? Okay, somebody's in already, so if he can get in, you guys can get in. It might take a minute to get it loaded. Use scratch paper to do, to process this. You're not going to be able to do this in your head. No way. So use scratch paper to try the problems. You work with the partner. You guys both answer the questions one at a time together. Don't finish the quiz and then say, how did you do? That's not working with them. Okay, so work with them on each problem. And then when you're done, hopefully, you guys will get some good results. Most kids are getting either 2 out of 3 or 3 out of 3 right. When you're all done, I will teach you more about common denominators and conjugates. Okay, so the quiz part should be over with. I see most of you guys did well, and this is the part where I teach you how to do common denominators. First of all, if you can't do a common denominator with this, then there's not much hope that I can get you to do a common denominator with trig, right? So would you please just add these together, get a common denominator? Hint, the common denominator is always easiest if you just make it the two denominators multiplied. So the common denominator here is 2x. So then what do you need to multiply by here? 2 over 2? No, that would give me a denominator of 4. So actually that's what you'd put over here. That would give me a denominator of 2x. What should I have done on the right side? Say it. X over x, good. And so then the top here becomes 2, and the top here becomes x, and then I can add them together. And unless you kind of lose brain function for a moment, you'll probably remember that it's just over 2x. Some kids say 4x, they're wrong. And then the top would be 2 plus x, or x plus 2. Raise your hand if you had that one right. Awesome. Now what this is leading up to is problems like this. I'd like you to take tangent theta plus cotangent theta and prove that when you put them together with a common denominator, you get 1 over sine theta, cosine theta. Now this brings up another important point. Another trick besides, common denominators are involved. If you have any sense of context, that would make sense, right? And also though, if you can change all your problems into just sines and cosines, do you get tangent? Yeah, I know I could make it into cotangent. That'd be dumb. Because the answer's got sines and cosines in it. So whenever you can, change your functions, your trig functions there, into sines and cosines. And then I bet you'll be able to figure out how it ends up turning into 1 over sine cosine. Just get the denominator to work out first, and then the top will kind of take care of itself. All right, I'm going to pause for a second while you and your partner give that one a try. This is a prove problem. So I pictured you realizing, since I'd given a lot of hints about sine and cosine, that you should change this to sine over cosine. And you should change this one to cosine over sine. And then I hope you figured out that that would give you a chance to make a common denominator of sine cosine, like we wanted here. So you times this by cosine, and this by cosine, and this by sine, and this by sine. Who caught on to that? That's what I was going for. Okay, good. Then do you get that it's sine squared plus cosine squared? And do you know what sine squared plus cosine squared is? It's really 1. So there's be my first step, there's my second step, and here's my third step. This turns into 1 over sine theta cosine theta. And that's what I wanted to prove. Okay? Any questions on that? I know probably at least somebody was not like, oh, you can just change that to 1? Yeah. Sine squared plus cosine squared is 1. You can change it to 1. Okay. Raise your hand if you actually think you would have got that one right. All right. If not, what part got you? Just help. Why? What got you? Help me understand what you were thinking.
I forgot that sine squared plus cosine squared equals 1.
Okay.
I had something that.
How many of you got stuck right there? Oh, that's a lot of people. Thanks for saying it. Okay, cool. All right. Good. Now that you hear that, maybe it's just like, oh yeah, that's not that hard. Okay. That's called common denominators. Here's another one that's going to come up a fair amount, and it is conjugates. I'm going to teach this to you in a way that I think will work pretty well. If I say x plus 4, then I'm just going to tell you the conjugate. It's x minus 4. And what's special is when you multiply this out, you get x squared, and the outside and the inside are opposites, and so they just cancel, and it's minus 16. These two things are called conjugates of each other. X plus 4 and x minus 4. All right. So if I have sine theta plus 1 Take a wild guess what the conjugate of that is. Don't overthink it here. This is supposed to be easy. Sine theta minus 1. Yep. And when you multiply that out, you get sine squared theta. And then the outside and the inside are opposite, so they cancel. Minus 1. So my favorite saying gets to come up again. If you can factor it, you should. So remember that things like this can be factored. That could be factored into two things that are conjugates. Sine theta plus 1 and sine theta minus 1. All right, so when would we use this? You'd use it in a problem like this. What if I had 1 over 1 plus sine theta? And I said, prove to me that that actually equals 1 minus sine theta over cosine squared theta. So here's the thing that kind of gives it away when you're experienced. You go, oh, if this had been 1 minus sine squared, I'd be thinking just replace it with cosine squared. But it's not squared. See the other thing I put black parentheses around? That's not squared. So you should be thinking, oh, maybe I can use the conjugate. Multiply by the conjugate. And you'll put 1 here and 1 here. Because, you know, when you do that, you're really multiplying by 1 in a creative way. And simplify it down, and I think you'll like what happens. This is called conjugates. I'll pause for a second and give that a shot.